protection. Okay. Again, we have this one oscillator circuit to generating the necessary clock signals. Okay, to instruct the program, and then real-time clock. Okay, means real-time means keep on tracking the system components in real time. Okay, and then till that RTC or real-time clock we are discussing the previous classes. Correct now? Now today we are going to discuss about the next other component is the watchdog timer. Okay, see this is a very familiar components used in the all microcontroller and all microprocessor. Okay, there is a watchdog timer. See, a watchdog timer is simply a watchdog is a hardware timer for monitoring the firmware executions and resetting the system, processor or microcontroller when the program execution and it is a function of your watchdog timer. Suppose if any during the execution process, any errors will be occurred means the whole processing system will be answered. To work on that, we are using this watchdog timer. Okay, that's it. Every time should be monitoring the software executions, and also this can also help for the resetting the system. Okay, when during the program execution, right? Okay, and depending on the internal implementation, the watchdog timer increments and decrements are free running counters with each clock pulses and generate reset signals to reset the processor. Okay, if the counter reaches into 0 for down counting watchdog or highest count value of counting watchdog. Actually, how they implementing this kind of watchdog timer is based on the increment and decrements. Okay, increment decrement by using the counters. Okay, the counting it may be up counter and it may be a down counter. Okay, but here the counting up and down that will be based on your signals. There's a clock signals. Okay, see in this type counters we are already know about the counters that things are discussed in the DSP, in the system. It means they counting the numbers. Maybe up counter means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like that. Down counter means okay, less than to higher. Okay, suppose 10, 9, okay, 7, 5. Okay, that is a down counters. Okay, if you go for example for counting. That's a real-time example. So the EVM, electrical voting machines, or voting machines. Okay, that is one of the best example for the counter. Similarly, down counter means during the satellite communications. Then during the satellite watching time, they will use this down counters. Means this watchdog timer are implemented by using this counters. Okay, and if the watchdog counter is means how to develop this watchdog counter means by using the flip-flops. Flip-flop is nothing but it is a storage element. Okay, it's a bit storage of the element. Okay, here we have found to count a number of numbers means we are using a number of flip-flops to count the data. Okay. Here also same thing. They are using this kind of functionalities using these flip-flops are used to make counting the up and the or increment and decrement. Okay. If the watchdog counter is in the another state, the firmware can write to 0 to 0 for counting watchdog implementation. Okay. Suppose it is okay. Wait a minute. Hello. Is this audible?
Sure.
Sir, your voice is breaking,
Okay.
sir.
Which model?
Sir, this is model number 3, sir.
ವಾಯ್ಸ್ ಸರಿಯಾಗಿ ಕೇಳಿಸ್ತಾ ಇಲ್ಲ.
Okay, okay, sir. Check ಮಾಡ್ತೀನಿ ನಾನು. Check ಮಾಡ್ತೀನಿ.
Good morning.
Okay. Now it is audible, no?
Good morning to all.
Good morning, sir.
Voice.
Not- Sir, now it is audible, no, sir? Hello.
ರಮೇಶ್ ರೀ.
Hello, Ramesh. Sir. Hello, Ramesh. Are you there? Hello. Hello. Okay, now it is audible, no? Yes, students. Now
Yes,
it is
sir.
audible. Okay. See,
Yes, sir.
see, this kind of watchdog timer will be implemented by using the flip-top also. That is nothing but counters. Okay, using the counters, we can implementing this watchdog timers. See,
Arjun, which model?
sir, model number 3, sir.
Model
Sir?
number 3. Knowledge
sir.
level 3 or 4? Apply or
Knowledge
analysis?
3, sir. 3, sir.
Okay, continue.
Okay, sir. See, if you want to count a number of data means we are using the counter. Suppose if you go count means if you go for the means the down counter, again they are using the counters. Okay, out to this the counter will be implemented by using the flip flops. Okay, here also in the embedded system also there is a watchdog timers are implemented externally or internally inbuilt will be there. Okay, if the watchdog counter is the enable state, it is the enable is nothing but on state. Okay, the software can write a 0, okay, to it before starting the execution of piece of code. Okay, and the watchdog will start counting. Okay, for each instruction what happen, they will counting the data. Okay, that's a up counting. Okay, for this condition what happen, where the up counting watchdog will be implemented for each and every execution stage, it will be counted. It start the counting. Okay, suppose in this software execution does not complete due to the manipulating the within the time required by the watchdog to reach the maximum counts, and the counter will generate the reset pulses, and this will reset the processor. Okay, you see where we are using this watchdog timer means during the execution time. There is the processor is cannot able to run this particular program. Okay, it means that during the hanging time, this watchdog timer will be reset the programs. Okay, that's why the watchdog timer will be used in the embedded and microcontroller systems. Okay, that's why for each it is enable means they will count each instruction instruction. Okay, so before starting the execution of piece of code, and watchdog will still starting the count. Again, similarly, if the frame where execution does not complete, okay, due to the manufacturing means there is a variation, there is an interrupt, there is an error will be occurred during the execution process within that particular time. Okay, then watchdog will reach the maximum counting, and they will use the signal to the processor to reset it. Okay, that's why the counter will be automatically, it should generate the reset pulses. Okay, and this will reset the processors. Okay, same as it is. Okay, suppose your laptop is there, so it is hanging means what will you do? You'll go for the reset only. Okay, if you have to reset, that means the program, all the program, what are the programs are the is there in the your system processor, each program will be reset. Okay, see one more example means suppose if your system will be hanging out means don't turn off. Okay, you should give a reset. Reset of there is a 3 options will be there, shutdown and reset. There's a 2 options will be there. Okay, shutdown and reset. If it is hanging means if you should give the reset. Okay, then only your process will be again once again will be reset it. Okay, if you suppose if you give the turn off mode means just turn off that one. Okay, if you again will be turn on means the same thing. What is the previous cases, previous display will be there now functionality. The same thing will be appear in the next also. That's why you see, if you want to go reset, if you want to use a reset command, then again everything will be resetted and will be and once again will be start. The come to the new means again we should again ಏನ್ ಮಾಡ್ಬೋದು ಅಂದ್ರೆ again ಮತ್ತೆ ನಾವು program ನ from starting from the beginning executed. Okay. Again, the firmware is nothing but software. Okay, don't confuse that. What is this firmware? Okay, there is a software execution completes before the expiration of the watchdog timer. You can reset the count by writing to 0. Okay, for an upcounting watchdog timer to the watchdog timer register. And then the most of this, see, this is the software execution supervision. Okay, it means that watchdog will be monitoring the execution, software execution program in the processor. Okay, correct now? That is the main function of this watchdog timer. Okay, most of the processor implemented watchdog as a built-in components. Okay, most of the processor now we get the advanced processor there now. Okay, each and everything there's a watchdog timer will be inbuilt, and the provides the status register to control the watchdog timer. Okay, like enabling or disabling. Okay, and watchdog timer register for writing the count value. And then the processor or controller does not contain a built-in watchdog timer. The same can be implemented using the external watchdog timer IC. Okay, there is IC also provided. That is externally you can connect the this watchdog timer. Okay, externally. And then external watchdog timer use the hardware logic for enabling and disabling, resetting the watchdog count, etc. Instead of software-based writing the status and watchdog timer register. And then some of the ICs are used for this watchdog timer. That the IC is equal to PS 1, 2, 3, 2. Okay, this is the externally we can. Okay, this is the external IC. That's a watchdog timer IC that will be connected to your processor or your controllers. Okay, and then in modern system running an embedded operating system, the watchdog can be implemented in such a way that when a watchdog timeout occurs, an interrupt is generated instead of resetting the processor. Okay, in general in your phones also. Your phone also one of the means high level embedded system. Correct now? Okay, and in our phone also we can. There is a reset options. Okay, suppose during any execution during the execution time, this application will be interrupt means what will do means we'll go for the resetting the processor. Okay, that is means the watchdog time means why error will be occur means within that particular time the software is not executed properly. Then what happen? The error will be occurred in the execution. That's why it causes the hangout in the system. Okay, to overcome that one, we are using this watchdog timer to generate the reset pulses for the resetting the processors. Okay, again the interrupt handler for this handle the situation in appropriate fashion. And then we can see this is one of the this one. What is that? Block diagram for watchdog timer, how synchronize with how to connect it with the microcontrollers. Okay, see this is a watchdog timer. This is a free running counters. Okay, it is audible now. Say sir now. Dear students, it is audible.
Yes, sir.
Okay. Thank you. Please hold a minute. Please hold a minute. Internet not connected. Please hold a minute. It will take some time. Now is presentation visible? Hello, do you see?
Yes, sir.
Okay, see, this is the figure. Okay, this is a watchdog timer for during the software execution supervision. Supervision is nothing but monitoring. Okay, see the watchdog. This is a free running counters. This is the system clock. Okay, and then this is the processor. This is a reset phase. Okay, for every execution, what happen? This watchdog timer is monitoring.
It's not clear.
Hello, it is clear now. Hello.
Yes, sir. Now it's clear.
Okay, see, in this, the watchdog, the external watchdog can see this example for the watchdog timer means externally we can connect this type of components to your processor, to the processor. Okay, this example for how to implementation of the external watchdog timer based on the microprocessor supervisor circuits for a small scale embedded system. Okay, in your mobile phones, in your i-generation laptops, in everywhere we are inbuilt watchdog timer will be there. What is the function of this watchdog timer means supervisor for your programs. Okay, you can see there is a watchdog free running counters and then microprocessor and microcontroller, that's a reset pins. Okay, okay, within separation time the program is not executed means there is some error will be occur in the processor. That's why the watchdog timer will be immediately okay. That's send the reset pulses to the microcontroller to reset the old systems. Okay, and again one more thing you can observe in this figure, there is a clock box. Okay, there is a clock box will be inbuilt, or you can also use some of the crystal oscillators. Oscillators we can generate in the clock pulse for execution of programs. Okay, that's why here also we can see the same clock pulse can I use both watchdog timer as well as the microprocessor controllers. Okay, then the final component. Okay, there's a PCB and passive elements. Okay, what are the passive elements? What are the passive elements? Tell me. See, we have active and passive elements are there. No? What are the passive elements? Hello? Dear student, it is audible now. What are the passive elements? What are the passive components? See, already I've studied network, everything already you studied. In basic electronics also we are studied about the passive and active circuit elements. Okay, what is passive? What is passive elements? Tell me. Hello.
Capacitor, sir.
Which one, passive or active?
Resistor, capacitor.
These are the passive or active elements. Okay, we are telling resistor, capacitor. Okay, it is a passive or active elements.
Passive.
Okay, this is the passive elements. Then what are the active elements? What are the active elements? What are the active elements? See, the active element is nothing but voltage source. Okay, and then some generators. Okay, and then some transistors, diodes. Okay, these are the active elements. Okay, and passive component is nothing but like very simple. These passive elements is an electronic components which can only receive energy. Okay, receive energy or some energy will be absorbed or some energy will be stored or some energy will be dissipated. Okay, innate and magnetic states. Okay, those things are the passive elements, like resistor, inductors, and then capacitors. Okay, these are the passive elements. Okay, active elements is nothing but to supply the, okay, these are the components. They can supply the energy to a circuits. Okay, and also these active components can controlling the flow of current. Okay, what are the example of these active components are voltage source, DC current source, generator. There's a DC generator or AC alternators, and also different types of transistors, diodes. Okay, these are the thyristors. Okay, these are the active components. Means you can controlling the flow of current. Okay, means there's a controlling elements. That is called as a active components. And passive component means you can absorb. Absorb is nothing but what? Energy will be absorbed, energy will be stored, and energy will be, the power will be dissipated. Okay, like a resistor, inductor, and then capacitors. Okay, these are the active components. See, in every embedded system, okay, there's a passive components are there with PCB. Okay, there's a printed circuit board. Okay, there's a PCB board will be there, and then passive components also will be there. The printed circuit board, there's a PCB is the backbone. Okay, this is our main important. There's a backbone of your embedded system. For every embedded system, the PCB will be there. For if you can open your laptop, your mobile phones, or any appliances. Okay, in everywhere there is a the printed board circuit board. There's a PCB board will be there. There we are mounted, deployed some of the components, passive components, processor. Okay, and then connection ports. Okay, everything will be implemented. That means all the components will be deployed in the circuit board. It's a printed circuit board. Okay, after finalizing the components and the interconnection among the schematic design is created, and according to the schematic, the PCB is fabricated. Okay, see how to make this PCB means if you want to make design any one system or any one devices. Okay, okay, if you go for take an example for rectifier circuits, you want to design the rectifier circuits. Okay, see first what you do means first you have to do the design part and identify the circuit elements. After that you go for the interconnections. You do the simulation. In the simulation only you take on the what are the design values you take and you do the interconnection and simulated. Okay, then we'll get the proper output. Then we'll get the schematic diagram from the software. Okay, the same schematic diagram means circuit diagrams will be implemented in the PCB board. Okay, there we are interconnecting all the components in the board only. Okay, and then this PCB acts as a platform for mounting all the necessary components as per the design requirement, and also it acts as a platform for testing the embedded softwares. Okay, this also one. See, before going to install that particular PCB to your appliances, means before going to that, you should do the designing. Design the board. Okay, it is connected or it is not connected. That what are the components where are deployed in the this one? What is that? In the board, it is working or not? Everything will be checked, tested. Then we'll go for that PCB will be implemented in the particular applications. Okay. That's why this also the PCB is also acts as a platform for testing the embedded firmware. And then apart from the subsystem mentioned already, the passive electronic components like resistor, capacitors. Okay, diodes is active. Okay, passive and active. You can change it. Both will be there. Passive and active components are both will be there in the particular embedded systems. Okay, active components, power supply. There's one example. Okay, they will give some supply, some current to drive the particular circuits. Okay, that's called the active components. Okay, okay, you can see, observe all these active and passive components are there in the board. Okay, if you go and check it, any old mobile phones are there, or any old some embedded system appliances will be there. You can check it. All these things will be mounted on the PCB board. Okay, and then there are co-workers of various chips contained in the embedded hardware. They are very essential for proper functioning of your embedded system. For example, providing a regulated ripple-free supply voltage to the system, the regulator IC and suppressors, filter capacitor are very essential. Okay, if you are given the see for your board, how much voltage has given? Nearly 5 to 10 volts, plus or minus 5 to 10 volts will be there. Okay, how to get this voltage means we are using the regulator. ICs are used to convert to AC to DC. Okay, in the DC also we contain some of the AC components. To suppress this AC component, we are using the some of the suitable capacitor as per your design requirement. Okay, you can design the proper capacitor. You can mount it. The means you can add the, you can connect the capacitor across this of the regulators. Then automatically what happen? We'll get the smooth unidirectional precision output voltage. Okay, there's the example. Example for your this one. What is that? Active components. Okay. Okay, these are the important things. Okay, these PCB and passive components are the inbuilt. There's the inbuilt components in the embedded system. Okay, there's a main part of the embedded system. Okay, without PCB, no embedded components. Means embedded project is not there. Okay, means what are the things you have studied? Means before going to after designing the things, then you go for the simulation. They say the same simulation will get then will be entered on the PCB. That is called a schematic diagram. There is a circuit diagram of your whole system that should be printed in your PCB. Okay, that is your main backbone of your embedded system. Okay, clear about this one? Any doubt regarding this? Any doubt? Hello? Yes or no? Hello? Dear students?
No doubt, sir.
Okay, see, this is very important thing in the embedded system. Okay, then okay, there is some reference are given here for about discussing about the this one. What is that? Embedded system. Okay, components. Okay, there's a Tata McRae 2009 editions are there, and then embedded system architecture program again will be Rajkumar. Again 2008 Tata McGraw Hills. Okay. If you why I'm giving this reference is if you want more information about this particular model, you go for this textbooks. Okay, this is a reference book. This is not textbook. This is a reference book. Okay, till we are completing the module 3. Okay, clear? We are completing the module 3. Hello. See, once again, okay, once again, what are the main components are there in the embedded system? Once again, we go for the revision. Okay. See, in the module 3, we are discussing about the some examples. Okay, what do you mean by definition of the embedded system? Okay, in the definition of the embedded system, initially I told it has a combination of 3 components. One is the hardware, software, and the mechanical components. Okay, these can use to, it is supposed to do a specific task only. Okay, and then we are given an example for embedded system: mobile phone, washing machine, air conditioners. Okay, these are some of the examples. Okay, we have a hardware circuits and software circuits. I mean, software part will be there, hardware part and mechanical also will be there. Okay, if you go for your this one, what is that? Air condition or washing machines. There's some buttons are there. Okay, these are the hardware components. PCB, everything the hardware components. Software means the programming. Okay, the drive control and monitoring the different variation modes. Okay, that is your software programs. Mechanical component is there's a chassis. Okay, there's a input and output control. Okay, output of water controls. Okay, these are some of the mechanical components. Hardware component is nothing but display board, buzzer, circuit boards, and then some buttons. Okay, these are the hardware components. Okay, that is the main basic thing. Definition of the embedded system is it contains the combination of 3 types of components: hardware, software, and mechanical component, and it is supposed to do a specific task only. Okay, and after that, we are discussing about the difference between the embedded system and then general purpose computers. Okay, we have some criteria are there. Okay, contents, operating system, alternation, key factor, power consumption, real time. Okay, based on that, we have a comparison between the general purpose computing system as well as a embedded system. Okay, after that, we go for the classification of the embedded system. In the classification, we have four criteria based on the some criteria. We follow some four criteria. We classify it as four types. One is the different based on the generation. Generation means first or second or third or fourth, like that, and based on the complexity and performance, and also based on the behavior, and based on the triggering, how to turn on. Okay, based on this we can classify it. Okay, in the generation, okay, there's a first generation, second generation, third generation, fourth generations. Okay, means each generation the building of microprocessor and microcontroller with different bits, and they can use the different applications. Okay, suppose you can take an example for 1G. There's a fourth generation, it will be 8-bit microprocessor, and then they can use the simple hardware and software development. They can use for that. The example for first generation microcontroller microprocessor is the digital telephone keypad. Second generation, the built-in 8-bit or 16-bit. Example is the SCADA. Third generation is built around 32-bit. Okay, example. That means they in this third generation they will introduce some concept. There's a DSP concept. Otherwise, ACI, ACS. Its applications are specific integrated circuits are introduced. Okay, then can use for the robotic and media. And similarly, 4-bit example is the 64-bit built processors. Okay, they'll introduce the concept of system on chip. There's a SoC. And then multi-core processor are evolved in this stage. Okay, example is a smartphone or laptops. And second, the classification based on the complexity and performance. There is a small scale, medium scale, and a large scale. And also deterministic behavior means that system will be work on real time or based on that can classify. And also final classification will be on triggering. Okay, based on the system will be reactive in nature, can be based on the triggering. Okay, it may be event triggered or it may be a time triggered. It means that event trigger after completing the event, one complete successful event, then it will be turned on. Or otherwise, after completing the some time duration, again it will be start to turn on your embedded system. There is a triggering. Trigger means to turn on. Either it can be event or it can be a time. After that, we are discussing about the application of the embedded system. In the application of an embedded system, you can see there's electronics devices we are used, and then household applications, automotive industries, telecom, telecom, and then computer peripherals, computer networking, healthcare, banking and retail, and card readers. Okay, these are some of the examples for embedded system application. And then purpose. Okay, the next is the purpose of the embedded system. The purpose means what is the necessity for using this embedded system. Okay, the first one is the data collection, storage, and representation. Example is the camera. And second is the data communications, means through Wi-Fi, through Zigbee, through USB. Some of the wireless modules are used to communicate the data between the two system or two users. And then data signal processing. Okay, signal processing like speech coding, audio, video, codec transmission application that are using this. This is one of the example for means necessary for processing the signal, the data signal processing. And fourth one is the monitoring. Okay, see all the embedded system, you can see there is a monitoring functions are there. Okay, to monitoring the systems. Okay, and then finally control. Okay, the control functionality contains both sensor and actuators. Okay, that should be connected to the input port for capturing changing the environmental variables, and the actuator will be connected to the output port or controlled according to the changes in the input variable. Okay, and next is some of the application specific user interfaces like buttons, keypads, lights, bells, display units, and mobile phones is the example for the application specific user interfaces. Okay, and okay, these are the necessity. Why are using this embedded processors? These are the purpose we can use for the this embedded system. And next is the core of embedded system. Okay, we have the 4 cores will be there, 4 categories will be there. One is the based on the general purpose and domain specific processor, and second was the application specific integrated circuits, and third one is the programmer logic devices, and fourth one is the commercial of the self components. Okay, nowadays the general purpose and domain specification process are generally used processor. Okay, nearly 80 to 90% of embedded system built on this general purpose and domain specific vector processors. Okay, again, there's a kind of example is the microprocessors. Okay, and then and then after that microcontrollers. Okay, and then digital signal processor. Okay, these are some of the general purpose and domain specific processor. Okay, and second one is the application specific integrated circuits. And third one is the third one is there is a this kind of application specific integrated circuit means this will perform a specific and unique applications. Okay. After that, there's the programmable logical devices. Okay, this also PLD is an electronic component to build the digital circuits, which is reconfigurable. Okay, it means that in this kind of microprocessor, we can reconfiguration means we can rewrite the code. Okay. And then last final is the commercial of the self component. There's the COTs. Okay, it is also this can also components of itself may develop around the general purpose or domain specific processor. And after that, we are discussing about the sensor and actuator. Okay, sensor is nothing but sense the input signals. What are the example for the sensors? It may be LED, LED light. Okay, temperature sensor. Okay, this is a sensor input signal. Like similar actuator. This actuator can be used as a output. Okay, it is a transducer. That may be either a mechanical or electrical, which converts signal to corresponding physical action. Okay, there's a what are these sensor and actuators elements components are LED. Okay, and then 7-segment display. Okay, and then optical coupler, and then relay, buzzer. Okay, again buzzers will be different types of buzzers will be there. Okay, like game show buzzer, timer, alarm devices, then confirmation of user input. Okay, and the sport events, household applications. Okay, this type of different types of buzzers are there. You can push button switches to turn on, turn off, to reset. We are using these push buttons. Okay, again, there's some of the communication interfaces. Okay, the artboard. See, why are you using this one means, see, if you taken a typical the standard embedded systems, we have a input, we have a output, and then we have processors, and also we have a communication peripherals. Okay, okay, these are the main components are used in the embedded system. Okay, again, we are discussed in the previous class communication interfaces. Okay, onboard or external types. Okay, onboard communication interfaces means these are used for internal communication for the embedded system. There's a communication between the different components present on the system, like integrated circuits. Okay, there's a serial peripheral interfaces, and UART. There's a universal asynchronous receiver transmitter, one-way interface, parallel interface. Okay, these are the onboard communication interfaces. It means that they communicate to the embedded system. Okay, internal communication of the embedded system, they use this onboard communication interfaces. Okay, and again, after that, we have serial data, and then we have SPI buses. Okay, there's a serial peripheral interfaces. Okay, then UART. Okay, and then one-wire interfaces. These are the onboard communication. Okay, then parallel port, and then next is the external communication interface. External means external world. Okay, if you have to communicate. Okay, so how to communicate the sensor, how to connect the sensor to the embedded system means through external wires only. Through the external wires means how to get the information from the sensor to your embedded system through the wireless communication. Okay, there's the external communication interfaces. Okay, and the telecommunication, the RS-232. Okay, this RS-232 is a standard communication, external communication system. Okay, then after that, we are also discussing about the RS-232. It may be a 9 or it may be a 25 data pin. Okay, there's a 8 pin or 9 pin or 25 pin. Okay. Then USB. This is one of the important to get transfer or receive the information between the two system. Okay, if we take an example, master and slave communications. Okay, RS-232.5 also they communicated with the master and slave system. Here also USB also will be there. Okay, that's a universal serial buses. Okay, this is also standard type of connection for many different kinds of devices. Okay, actually the generally the USB uses to the types of cables and connectors used to connect this many types of external devices to computers. Again, there's a different versions are there. Okay, different types of versions are there. USB 3.1, USB 3, USB 2.0, USB 1.1. Okay, based on your data speed. Okay, we have different versions are there. Suppose if you go for USB 3.1, there's a super speed. Okay, nearly it may be a 1 giga. 10 gigabytes per second. Similarly, USB 3.0, it's also super speed. That is the previous USB 3.1 is the super speed plus. Okay, USB 3.0 is a super speed. Okay, the maximum speed will be a 5 gigabytes, and to USB 2.0 is a high speed. Okay, the maximum speed will be a 480 Mbps, and USB 1.1. Okay, the maximum speed. There's a full speed. The data rate will be a 12 Mbps. Okay, you can see observe in any computers. We have a different types of the USB ports will be there. Okay, they will given nowadays. The USB 3 port will be there, USB 2 port will be there. Okay, means for accessing, for receiving and sending the data between these devices, based on your speed, you can choose the port. Okay, then after that, then some of the wired communication, IEEE 1394. There's a serial buses are used. It is a type of star connected structure, and then there is some of the infrared data association. Okay, like Bluetooth, like 802.11 Wi-Fi, Zigbee. Okay, these are the wireless communications. Okay, again, we are discussing these are the wireless communication. These also we can use for communicate the external devices. And then GPRS also. Okay, there's a GPRS also can use for communicate the external devices. And then after that, we are discussed about the memory. There's a memories. Okay, we have different types of memories there in the system. There's a RAM. Okay, again we have different type classification. Memory will be classified into RAM. Okay, DRAM or static RAM or hybrid, non-volatile RAM or flash RAM or electronic erasable program RAM. Okay, then ROM will be there. Okay, EEPROM or PROM or masked ROM. Okay, that we have discussed in the previous class also. And after that, embedded softwares. Okay, and then we have some of the other components are used in the embedded system. There is the reset components, and then there's a brown out protection, and then oscillator circuits. Okay, and then is a real-time clock. Now today we are discussing about the watchdog timers. Okay, these are some of the other components are used in the these other components will be connected externally, or some of these components will be inbuilt with your system also. Okay, clear? Okay, these things we are discussed in this model 3. Okay, any doubt regarding this model 3? Any doubt? Say yes or no?
No, sir.
Okay, see here in the
No,
model
sir.
3, see fully theory part. Okay, nothing program, nothing program. No programs are there in the particular models. Okay, we are discussing about what are the components, devices are used in the embedded systems. Okay, and what is the necessity and what are the types of embedded system are there. Okay, that we are discussing this model 3. Okay, clear about this one? Any doubt regarding this? Any doubt? Hello? Yes or no?
No, sir.
No, sir.
Okay. See, this week is the last date for submitting the assignment. Okay, everyone submitting the assignment? Everyone submitted the assignment? Third assignment also will be there in the Teams. Okay, see, in this, wait a minute. The next class onwards, okay, the next class onwards, we are discussing discussing about the next modules, okay, for a year, for both 15 and 17 scheme, for both 15 and 17 scheme, the portion will be the second part will be off model, and then this one what is that? Third module full will be there. Total 1.5 modules will be there. Study all this topic. Okay. See due date of assignment 3 will be 27. Okay. Today is already 22. Okay. See only few students are viewed. Okay. What about others? Venkat Bhargav is not attending any single class also. Jayavardhan Reddy, why you are not viewed? Some students are submitted. Okay. See within 27. Within the 27, we should submit the assignment 1, assignment 3. Again, assignment 2. Okay, I will show that we can check it here. See, Elan Murthy is not submitted. Ramesh is not submitted. Okay. Again, Venkat Bhargava. Srinivas also is not submitted. Dilip Kumar, Sonika Reddy, Subramania Reddy. Why are you not submitting the assignment? Huh? Module 2. Srinivas, Sonika, why are you not submitting the assignment? Dinesh also. Already the date will be closed. Okay. Still you are not submitting. At least you are not requesting me also. Okay.
Sir, submitted both at the time, sir.
Where? What's your name?
Sir,
Murthy,
sir,
sir.
I have
I
submitted,
submitted both
sir.
assignments on the third assignment only, sir. On the same date.
Second
Sir.
assignment. What about second assignment?
Second assignment and third assignment, sir. Both have submitted on third assignment itself.
Why you do like this?
Sir,
There's an individual assignment
yes, sir.
will be there now. Again, similarly, okay, in the first assignment also. I'll show that one. Just
Sir,
check it. Yeah, tell
I
me.
have submitted the assignment, sir.
But it is not there now. I'm showing now.
I'll submit it at before 4 o'clock, sir.
Okay, again. First assignment, Murthy, not submitted. Ramesh is not submitted. Dilip Kumar is
I
not
have
submitted.
submitted, sir.
You can see here.
Sir, I have submitted, sir.
It is not viewed only. You are not submitted. Handed in, showing this handed in nothing but the submitted. If it's seeing viewed, only view that. You are not submitting that one. If you go check it here, where is your? Where your
Sir,
file is
I
not.
have submitted, sir.
That's why only initially I'm showing that each and every statistics only. Now only you can check it here. Okay. Dinesh also is not submitted. Subramania Reddy, Sonika, Dilip Kumar, and Srinivas. You are not seeds also. Okay, this is the last warning I'll give you. Once again, I will this one. What is it? Revise the due date. Okay, for first and second assignment. Once again, I've given the others due date. Okay, today I'm giving again updating that time. Today is the last date for submitting the first and second assignment. If you are not submitting means I put 0 for that particular class. Particular assignment I'll put it 0. That's it. Okay, clear about this one? Okay, today we'll stop here. We'll continue the next class.
Secondary.
Yeah, tell me. Okay, no, you can leave the session and join another session.
Thank you, sir.
Okay, thank you. See, those who are not submitting the assignment, today is the last day to submit the assignment. First and second and third is there, 27 till up to 27. First and second, today is the last date. Okay?
Okay,
Submit.